All right, so let's talk about how we go through the process of completing the square. So if you're given a quadratic equation and you can't factor it, up until this point, you'll be like, oh my gosh, how am I going to do this? Well, to complete the square, you can only use this method if the leading coefficient is 1. If the leading coefficient is not 1, you got to address that. You got to divide every term by that leading coefficient so that the leading coefficient becomes 1. Don't even think of using this process if the leading coefficient is not 1. So write the equation in exponentially descending order. Look at the leading coefficient. If it's not 1, divide by that number. Every term, get it to be 1, and then you can use this process. Okay, we're lucky. This one already has a leading coefficient of 1. So let's talk about how we're going to complete the square. The first thing that you want to do is you want to move all terms with the variables, in this case x, on the left-hand side of the equation, or on one side of the equation, isolate all terms that have a variable that we see. We obviously know the 3 is a coefficient of x to the 0 power, but let's not address that. That's 1. So I'm going to move all terms with a variable on the left side of the equation, and I'm going to move all constant terms on the right. Okay? Then I'm going to draw this plus and then a little blank space on each side of the equal sign. Okay, so let's do that. So these are my terms that have x. So I'm going to leave them on the left-hand side. This is a constant term, so I'm going to move that to the right-hand side by subtracting. And then I'm going to add something to each side, yet to be determined. Okay, move the constants to the right-hand side of the equation, doing the opposite operation. Leave the terms with x, or move all the terms with the variable x on the left-hand side of the equation, and then draw this blank line. Now, we have to figure out what we're putting in that blank. What are we adding to each side? The whole point of doing this is to complete the square so that I can factor the left-hand side of the equation. So to split the middle, we're going to split the coefficient of x in half and then square it. That's what you're adding to each side. So you're looking at this coefficient of x. So I have 6. Oops. I have 6. I'm taking half of that, which is 3, and then I'm squaring it. Take half of this and square it. That is what you're adding to each side. Okay? So let's rewrite the equation now. I have x squared plus 6x plus 9 equals -3 plus 9. So far, so good? So all I did, I wrote it in exponentially descending order. I looked at my coefficient of x. I took half of it. I squared it. I added that to each side. Why? Because now look at the left-hand side of that equation. You can factor it. What are my factors? Okay, so technically x plus 3 squared, right? So it's a perfect square trinomial now. What's on the right-hand side of the equation? Okay, now, since I have something raised to the second power isolated on the left-hand side of the equation, you know what to do next. What do? Take the square root of each side. Okay, so on the left-hand side, I have x plus 3. And on the right-hand side, well, I have plus or minus the square root of 6. I cannot take this. It's not a perfect square. There's nothing I can factor out of that radical. But I haven't solved for x yet. What's my last step? So what are my two values of x? X equals -3 plus square root of 6, and x equal -3 minus the square root of 6. Those are my two values of x. There is my solution set. Yes, ma'am.
For our answer, could we just put x equals -3 plus or minus the square root of 6?
Yes, you can, but if there's a chance where you could simplify it further, you'd have to simplify it further. Right now, that's fine.
Okay.
Yes, but and when we get to the point where we would have to separate it and do something different, I'll let you know.
Because you're saying like if it was like a 9 in the square root, we would have to
Yes.
Okay.
Yeah. Oh, you are so smart. Yes, ma'am. You got it.
Okay.
You got it. Okay. I can't combine those, so I leave it. Yeah. All right. What about the next one? Let's complete the square. What is the first thing that we check? Is the leading coefficient 1? Yes, it is. Oh, gosh. I hate when it does this. Oh, gone. Okay. All right. So let's go ahead and move all terms with the x on the left. Already there. Oh, our constant is just 0. It's already on the right. What am I adding to each side? Can I factor the left-hand side? What am what's my factor? And 9 on the right. Now what?
Now you
Square root each side. And then I get x plus 3 equals plus or minus 3, right? So at this point, we would have to separate it. So I have x plus, oops, sorry. Let's go one step further before we separate it. Let's go ahead and say x plus 3 equals 3, and x plus 3 equals -3. Solve for x in each. X equals what?
0.
And -6. There are my two solutions. Now, of course, we do want to get in the good habit of checking all of our solutions to make sure that none of them are extraneous. Next one. Here we go. Oh my goodness, what do I do first? I am. I cannot complete that square. If the leading coefficient is not 1, so I have to divide every single term by 3. Which is going to give me x squared plus 2x plus 2/3 equals, what's on the right-hand side? 0. Next step. Move the constant to the right side of the equation, leaving the terms with x's on the left. What am I adding to each side? Very nice, right? Half of 2 is 1. 1 squared is 1. Factor the left-hand side of the equation. Woo. Get a common denominator and add the terms on the right. What do I get? 1/3. Can everybody get 1/3? Okay. So then I square root each side. And I get x plus 1 equals plus or minus square root of 1/3. Do I stop there?
No.
No. So this is x equals -1 plus or minus the square root of 1/3. But I'm very uncomfortable with that radical. I'm gonna separate it. Yep. So I have x equals -1 plus or minus
The square root of
And so therefore my two solutions are x, e, and you could leave it like that. Oh, no. Or you could separate it. I don't care at this point. I'm fine. Either one. This or that. Now, we know the process of completing the square. We address the leading coefficient. If it's not 1, we divide everything by 1, right? Once you do that, you move the constant term to the right-hand side. We figure out what we're adding to each side by taking half of that coefficient of x and squaring it. Factor the left-hand side, square root property, and we have x equal the solutions. So what I want you to do, for those of you who are online, you are taking this and you're writing out the steps on how you would complete the square. At the end of your answer, once you perform completing the square on this, complete the square to solve for x, you're going to get x equaling something. That's what you're supposed to figure out. So if you are online, you are doing that now. Those of you who are in the room, I have little strips of paper. And these are all the steps to complete the square. So I want you to rearrange them using the correct process, and you'll get the answer. When you think you got it, let me know. You will need to know this. Before we leave today, we'll make sure everybody knows this. But once you finish this, you can take a picture and then write it down after we've agreed that you've done it correctly. You do need to know how to derive this next formula. Okay? So you are completing the square on the quadratic equation, and you're solving for x. Using the strips of paper, once you think you got it, I'll check it, take a picture, write it down, or copy it down. Once you finish that, I have a little fun activity. Fun activity. For those of you who are online, it's on Canvas. I will publish it after everybody has had a chance to complete the square on this. This is a maze. Using complex numbers. Follow the instructions. Color the maze, make it pretty. When you finish it, scan it, submit it to Canvas. It's 5 points. We're doing it in class. Okay? We have more than enough time to derive this. Once I've said yes, you pick this up. Okay? So I'm going to give you the little sheets. Let me just stop this. Those of you online, please